Hey, we're going to talk about lesson 1.3. We're going to make and interpret dot plots of quantitative data. We're going to describe the shape, and then we're going to make comparisons between different dot plots. So, so a little bit of review. We had talked about a variable either being categorical or quantitative. Okay, categorical, we made a pie graph and also a bar graph. With quantitative, right now, this first one, we're going to look at a couple different ways over the next couple of days, but the first thing we're going to look at is a dot plot. Okay, so a dot plot, basically, the basics of it is you create a line, basically a number line, 0, 1, 2, 3, 4, 5, etc. And you can scale that however you need to. And then you just basically put a dot for everything of your data. So the number of siblings people have. So say someone's an only child, they have no siblings. Me personally, I have a sister who lives in New Jersey, and I have one. My kids, I have 3 kids, so they have 2 siblings. Let's say my wife, she has 2 siblings as well, so we put another dot above. And we would just keep adding dots for every person that we take data for, and so forth. You want to make sure the first lines kind of line up, second, etc. So you can see how that there is more in this one than there are in the other ones. That's the basic idea of a dot plot. Okay. Now, when I'm going to ask you to describe these dot plots sometimes and other data as well, and we're always going to think. I want you to think socks. Okay. Not quite like what's on your feet, but socks. Okay, socks. We want to think about what is the shape of the distribution. Are there outliers in the distribution? Where is the center of the distribution? And the spread of the distribution. Okay, we'll talk some about these a little bit later. Let's talk about shape right now. Okay, we're going to talk about this, our dot plots or distribution of our data being one of these things. We're going to be uniform. Okay, we're going to talk about it being roughly or approximately symmetrical. We're going to talk about it being skewed, and it can be either to the right or to the left. So right skew and left skew. Okay, so a uniform distribution will basically just be the same all the way across. It won't have any peaks and valleys. It'll just be every single one of our categories or numbers. So 0, 1, 2, 3, 4, they all have the same amount in each one pretty much. That's called uniform. Approximately symmetrical. Okay, symmetry, like the letter A, has symmetry down the middle, right? Where it's the same on this side and it's the same on that side. So we're looking for symmetry on both sides of the center, okay? So if you look at this one right here, this one is fairly symmetrical, okay? So this is going to be my middle here, and it's kind of the same on this side and this side. So we would say that's approximately symmetrical. Okay, the skew, if I look at this data, this right here, this would have a skew to the right, okay? So if you think about it being symmetrical, symmetrical would be about like right here, right? So we have more data over here that skews stuff to the right, okay? Whereas this one here, okay, here's roughly symmetrical. We have more data over here which skews it to the left, okay? If I have the mean of this data, if it's fairly the mean is the average, if I take all this and average it here, and a symmetrical would be my mean. Whereas here, if I have some bigger numbers out here, my mean is going to be drawn in this direction. And here, if I have these numbers here, my mean is going to be drawn in this direction because of these lower numbers. So very important to know, roughly symmetrical, skewed right, skewed left. So other things you might want to notice sometimes, I know this is in AP, they look for this in AP statistics. If you have a graph that looks like this, notice there are 2 peaks to it with a valley in between, okay? Old Faithful, I don't know if you've ever been to Yellowstone out in Yellowstone National Park. I've been there twice. I love national parks, by the way. Anyway, that's a side note. Um, Old Faithful either is it's faithful because it's a geyser who spews the water whenever it sorry about the phone. It spews water pretty consistently. That's why it's called faithful. So it either goes at a 2-minute interval, or sorry, the duration of it, how long it's going. It either goes for around 2 minutes, or it spews for around 4.5 or 4.25 minutes. Okay, so it very rarely spewts water out of the ground for 3 minutes, let's say. So it's either centered here or centered here. So if it was a AP test, I'd want you to talk about that difference there. So anything unusual you want to talk about too. Okay. The other things here, outliers, we'll talk about that a little bit later. But if I have a bunch of data right in here and I have one way out here, that's probably considered an outlier. And we'll talk about how we find that later. Center, we're going to talk about median and mean. Those are our two centers we're going to talk about. And spread, we're going to talk about the range. If you remember back in Algebra 1, range is the difference between these two. So this is a range of 4. We're going to talk about interquartile range, and we're going to talk about standard deviation. Okay, so that's something that's coming up in another lesson here sometime. Okay. So another big thing I'm going to ask you to do is to compare the distributions. So I might give you 2 dot plots and I want you to compare those. So I want you to always think about SOCs and how would you compare these. Okay? So when I ask you to compare, I want you to use language like this is greater than that, or this is about the same as that, or this is less than that. Okay? So this is household sizes in South Africa and the UK. Okay, so if you look at these distributions, let's talk about shape first. Okay, how would you describe their shapes? Okay, I would say this one here is skewed to the right. I'd say this one is roughly symmetrical. Okay, so that's the shape. Next is, outliers. Okay, this one does not appear to have any outliers. This one, I'd say that's probably an outlier. That family that has like 26 people in the family, that's kind of an outlier in that group. Okay, the center, okay, mean, median, or just the kind of the middle points here, center. I'd say this center here would be about, I don't know, about 6 kids. Okay, roughly about. And this one has a center roughly about maybe 4 kids. Okay. So I would say, because you want to use comparative language, the center of South Africa is greater than the center of the UK. Okay. Spread, okay, thinking this is more spread out than what this is. So I would say the household size of South Africa is more spread out than the household size in the UK. Okay. So we're looking at, make sure you use that descriptive language, greater than, less than, about the same, and think about SOCs. And that is all for today for 1.3.